Hey there, this is Professor Duresh, and this is part 2 of a 3-part video series on GCF factoring and factor by grouping. In the last video, we talked about what a greatest common factor was and how to identify it. And in this video, we're going to factor out the greatest common factor from a polynomial. So we left off on finding the greatest common factor between 10x squared and 15x to the 6. And we discovered that that common factor was 5x squared. If I rewrite the question just a little bit and say instead, factor the polynomial 10x squared plus 15x to the 6, I can take all of this scratch work and use it to factor. So I've written a sentence at the bottom that says the factored form of 10x squared plus 15x to the 6 is, and what I do is I write the GCF out front, and then in parentheses, I write the polynomial terms that are left behind. So if you look at 10x squared, the only thing that wasn't in common is 2. Plus, if you look at 15x to the 6, the only thing that wasn't in common was a 3 and x to the 4th. So we factor this 10x squared plus 15x to the 6 as 5x squared times 2 plus 3x to the 4th. And we can check that it's correct because 5x squared times 2 is 10x squared, and 5x squared times 3x to the 4th is 15x to the 6. So this is how we factor a GCF. And greatest common factoring is actually always the first step of every factoring problem, if it's possible. Let's take a look at another example. We're going to factor the GCF. This would be example 3. We're going to factor the GCF out of 2 polynomial expressions. So the first one is going to be 2x to the 4th minus 16x cubed. So I'm going to use maximum scratch work on this example, and then I'm going to show you how you can use less scratch work to get the same answer. First, we're going to break down the 2x to the 4th. 2 is already prime. There aren't any smaller numbers that make 2. So I can rewrite this as 2x, x, x, x. This one, 16 is not prime. 16 can break down as 2 and 8 or 4 and 4. So if I break 16 down, first as 4 and 4, I can then break it down as 2, 2, 2, 2. So I'm going to rewrite 16 as 2 times 2 times 2 times 2, x, x, x. What do these terms have in common? They each have 2, and they each have 1, 2, 3 x's. So we write out front 2x cubed, and then in parentheses, we put what was left behind. X minus 2 times 2 times 2, or x minus 8. And that is the factored form of the original polynomial. In the next example, we get 4x squared y cubed plus 20xy squared plus 12xy. Now let's try to approach this one with less scratch work. And the amount of scratch work you show is just going to be based on your comfort level with each individual problem. So looking at the 4, this is our smallest number, so this is where I'm going to start for my greatest common factor. 4 is divisible by 2 and by 4. Is 20 divisible by 2? Yes. Is it divisible by 4? Also yes. Is 12 divisible by 4? Yes. The GCF of the coefficients is the number that divides evenly into all 3 coefficients, which in this case is 4. Now I want to see how many x's I can have in common. What's the most number of x's? This one has x squared. There's 2 x's in the first term. Does the second term have 2 x's? No, it just has 1. So right now, 1x is the most I have in common. Does the third term have 1x? Yes, all 3 terms have 1x. Do all 3 terms have 1y? Yes. Do all 3 terms have 2 y's? No. The greatest common amount of y's I can take out would be 1. And then I have to ask myself, what would be left in each term if I took out a 4, an x, and a y? Now remember that factoring is the opposite of multiplying. So when I say take out, I'm not saying subtract, I'm saying divide. 4 divided by 4 is 1. X squared divided by x is x, and y cubed divided by y is y squared. You can put the 1 in front. I did not because it's not standard. Does 4xy times xy squared produce 4x squared y cubed? It should, if we factored correctly. And then we keep going. You can do 20 divided by 4 in your mind, or you can ask yourself 4 times what is going to give you 20. If you take out the x, there won't be any x's left. If you take the y, there should be 1 y left. Last one, 12 and 4 leaves a 3 behind. If you take out xy, there's only an xy, so there's no xy at the end. This is the factored form of this. All right, in the next video, we're going to talk about factoring by grouping, which uses greatest common factor factoring to factor longer and more difficult polynomials.